Hi. So, yesterday we solved quadratic equations by using the quadratic formula. Today we're going to use a different method. We're going to solve quadratic equations by completing the square using its procedure, which we're going to talk about. So, here is the procedure. And again, we always want to try and factor. Factoring is generally the easiest way to solve quadratic equations, but if they don't factor, then I have to use either quadratic formula or completing the square. Sometimes I think quadratic formula is easier, sometimes I think completing the square is easier, and we'll talk about that as well throughout this lesson. So we're going to refer back to these notes as we go through, but if you want to take a screenshot of them, here they are. They're also in the front of your packet. We want to bring both variables to one side and the constant term to the other side. And we want to divide out a GCF if possible. So there is no GCF here. And yes, this is in the proper form because I have all the variables on one side and the constant term on the other side. So it's time to complete the square. So I'm going to add this big blank square to both sides. And to determine what goes inside that square, it's b over 2 squared, where b is the same b as the quadratic formula lesson. It's what's in front of the x. So in this case, it would be negative 6 over 2 squared. Negative 6 over 2 is negative 3 squared, which is 9. That's step one. Now, my next step is to factor the trinomial. Two sets of parentheses, x and x. First sign comes down, negative and a positive is a negative. Now, there's two ways of looking at this. It will always be the same factor written twice when I'm doing this procedure. So you can look at it as factoring what multiplies to 9 and adds to 6. Well, 3 and 3. Or it will always be the square root of that value. Whatever the square root of that value is, that will always go in each of those. My right-hand side, 9 plus 9 is 18. Now, x minus 3 times x minus 3, x minus 3 times itself, well, that's what squared means. So I'm going to rewrite this as a binomial squared. And that is completing the square. There's a lot of different applications of completing the square. If you took geometry last year, you used completing the square to find the center of a circle. Now we're going to use completing the square to solve equations. So I'm going to now take the square root of both sides to get rid of the square. When you take the square root of something, it's plus or minus radical 18. Now I'm almost done. I want x by itself, so I'm going to add 3 to both sides. Write the number first, plus or minus rad 18. Now your final step, if necessary, if possible, you want to try and reduce the radical. Again, this is the first lesson of this unit. It becomes 3 rad 2. So your answers are x equals 3 plus or minus 3 rad 2. That's the first example. It's pretty much the same procedure for all of them. It's just a matter of getting practice with them and getting them into the proper form. Number 2, is this in the proper form for completing the square? No, it's in the proper form for factoring and quadratic formula, but for completing the square, I need the variables on one side, the constant term on the other side. So I'm going to start by subtracting 6 from both sides. I get x squared plus 4x equals negative 6. Now it's time to complete the square, so I'm adding my square to both sides. To determine what goes inside my square, it's b over 2 squared. B in this example is 4, so it's 4 over 2 squared, which is 2 squared, which is 4. Next step, factor the trinomial. It's going to always be the same factor written twice. and we're taking the square root of this value. Sorry about that, the phone rang. So again, when I'm factoring the trinomial, it's always the same factor written twice, and a little shortcut, it's going to always be the square root of that perfect square in the square. My right-hand side, -6 and 4 is -2. Now I want to rewrite this as a binomial squared, and that's completing the square. Now to solve this equation, to get rid of the square, I do the square root of both sides. The square and the radical cancel, and when you take the square root of something, it's plus or minus. Isolate the x by subtracting 2 from both sides. I get -2 plus or minus radical -2. The final step, if possible, is to reduce the radical. Well, I can't do much, but that negative inside the radical should not be inside the radical. It comes out, it becomes an I. That's your answer. All right, let's just do one or two more, and that's really it. Let's skip ahead to number 9. So, I need all the variables on one side, the integers on the other side. So I'm going to subtract 8x from both sides. And I get this. Now, for completing the square, I can't have anything in front of the x squared. So whatever's in front of the x squared, I have to divide it away. Whether or not it goes in evenly, I have to divide it away. In this case, it does go in evenly, but even if it didn't, and I ended up with fractions, I would have to deal with that. X squared plus 2x equals -4. Now I'm in the proper form, so I complete the square by adding the square to both sides. I want you to try and finish this problem from here, so I'm going to ask that you pause it, complete the problem from here, and now that you tried the problem on your own, let's see if you got it. To determine what goes inside the box, it's b over 2 squared. B in this example is 2. So it's 2 over 2 squared, which is 1 squared, which is 1. I factor the trinomial normally. Or it's always the square root of that perfect square value. My right-hand side is -3. Rewrite it as a binomial squared. That's completing the square. To solve the equation now, I take the square root of both sides. The square and the radical cancel. When you take the square root of something, it's plus or minus. Subtract 1 from both sides to get x by itself. If possible, reduce the radical. And just like the last example, there's not much I can do, but that negative comes out and becomes an I. And that's it. So, when should we do quadratic formula? When should we do completing the square? It's totally up to you. To be honest, in this course, completing the square isn't very necessary. You really don't need to use completing the square in this course. It comes up a lot more in Algebra 1, but I would use completing the square if a is 1 and b is even. So in this example, where there's nothing in front of the x squared and b is even, I would use completing the square. When you don't have that, it gets real nasty using completing the square, and I would just choose to use quadratic formula. In general, though, if you want to memorize one procedure, I honestly would stick with quadratic formula for this course, and you're going to see how you can use completing the square for a more complicated one, but how it gets kind of nasty. So, number 10 gets kind of nasty, so that's what we're going to do. Is this in the proper form right now? No. I need to bring the 26 to the other side. That gives me 2x squared plus 2x equals -26. I can't have anything in front of the x squared, so I need to divide it away, whether it goes in or not. In this one, it does go in, which is great. And now I'm in the proper form, so it's time to complete the square. I'm going to add my blank square to both sides. To determine what goes inside, b over 2 squared. b is 1 in this example. 1 over 2 squared is 1 squared, which is 1, over 2 squared, which is 4. Factor. Well, what adds to 1 multiplies to 1/4 and adds to 1? That's a little tricky, but it's really not bad because, again, I can just take the square root of that, and the square root of 1/4 is 1/2. Now, my right-hand side, you would need to add those. You'd have to find a common denominator, all that good stuff. However, you could also just type it into the calculator and cheat a little bit. Negative 13 plus 1/4 is negative 51 over 4. Rewrite it as a binomial squared. And now I take the square root of both sides. The square and the radical cancel. The top, so I get first of all plus or minus, radical negative 51 becomes I rad 51. The bottom, rad 4, is 2. Now I would subtract 1/2 from both sides, and I get as my answer negative 1/2 plus or minus I rad 51 over 2. I would not use completing the square for this example. I would use quadratic formula. I think if A is not 1 and or B is not even, in this case B was odd, which brought the fractions into play, I think it gets a lot nastier. Again, you can do it with completing the square, but I think it's a lot easier to do this particular problem with the quadratic formula. So if you got lost on this towards the end with the fractions, I really wouldn't worry about it. I don't need you to be able to do this example using completing the square. In fact, I really don't need you to be able to do completing the square at all. It doesn't really come up much, but it's something that you really should know taking an Algebra 2 class. You did it in Algebra 1, so it's another procedure, another method for solving quadratic equations. So your classwork/homework is going to be to finish solving quadratic equations using completing the square, and that's it. The next lesson is just going to be practice using completing the square and quadratic formula. Then we're going to use those in the following lesson. So really not much new over the next few classes. It's mostly just practice. Have a great day, and if you need any help, you know how to find me.